Bismillahirrahmanirrahim. Now our topic is the graph of sin x. We will discuss these graphs separately. So far, we are discussing only the graph of sin x. So let's see. Uh, I have drawn these few things here to explain the graph of sin x. You know, sine, the ratio of sin x is opposite over hypotenuse. So just look at it that the ratio is y is equal to opposite over hypotenuse. Sine x is equal to opposite over hypotenuse. Okay, now here in the circle, these blue lines, what do they represent? They are radius of the circle. Now at every point, this is approximately 30 degrees, then this is 45, and then this is this much, that is 60 degrees. Just remember that these lines are representing these angles because there is not that much space that I can leave them written over there. So I remove them, and this is, or let me write it here. This is 30 degrees, this is 45, and this is 60 degrees. Just keep in mind. Okay, now at this point, if we focus on these two things, opposite and hypotenuse, these two things, then hypotenuse is constant throughout. Then that means this is the value which is changing. And if I draw this line in a little better way, then it will be, this is opposite. This is the value of opposite when angle is 30 degrees. And then you can see that the value of opposite now becomes this much when the angle is increased from 30 to 45 degrees. And when the angle is 60 degrees, it is further increased. So you can say that the value of opposite increases when angle is increased. So as the angle becomes 90 degrees, then the size of opposite is here. Let me draw a line overlapping this. Now this red line here is radius, and this green line overlapping that red line, that is opposite. So I think now you can understand very easily that at 90 degrees, red and green lines are of equal length, and that means opposite is equal to radius as well as hypotenuse is equal to radius. So the ratio opposite over hypotenuse, that will become radius over radius, that is 1. Now if I consider these angles, like this is 90 degrees, this much, that would be approximately 45, this is 30, and this is 60. So in this first quadrant, what change is being observed over there? we can see that I use a light color. So that this line from here, this is 30 degrees. Can you see one interesting thing, that this green line, this one, this is exactly half of this distance. If this distance from here, this is 1, 2, 3, and 4. And for 30 degrees, it is coming here exactly half of that. And this is for, I have marked here 30 degrees. So this is the point of intersection of these two lines. Now 45 degrees against 45, once again you can see that this is 45. Keep in mind that I have not marked these angles accurately. These are approximate values. So for 45 degrees, it is approximately this much. And now 60 degrees, this is the value against 60, 60 degrees here, and this is 90 degrees. (90° is here, and if now we join all these points, this is not very perfect figure, but I have tried to mark such points. So now if we join all these points, this point and this point, this one, here, this is for 30, 45, and 60 degrees. If we join these points, we find it kind of curve this way. Similar curve as it is here, moving this way, we can find approximately same type of curve, and then you can see at this point equivalent to this one here, that will be approximately 120 degrees. Then this is 135, and against this one, this is 150 degrees. So same values are continued on this side, same values for 120, and on this side that this is 30, and this side that will be 150, and it in the curve comes like this here, and then this way, and then it comes back to 360 degrees, as if a point is moving this way upwards, the graph reaches here, and when it comes down here, then it comes down to this side. When it reaches here to 270 degrees, the graph reaches here, and then back to here. Okay, so this type of curve, this curve is known as sinusoidal curve. Sinusoidal curve. If one cycle is completed along the circle till here, then this curve, 4 quarters of the same curve, this 1 quarter, 2, 3, and 4 quarters are completed here. If we continue the next quarter, then it will continue this way again for another cycle. So this is the relation between opposite and the graph of y. As opposite increases, the graph moves this way, but after 90 degrees it comes down. So here you can see that you can never expect the value of the graph of sine more than 1, and the reason is that its maximum value is here, where opposite and hypotenuse are both are equal to the radius. So in this way you can draw the lines, and the graph moves this way. Okay, now I will try to explain the same thing in the graphing this software. Here you can see this equation, y is equal to a sine bx minus c minus d. What is the effect of these numbers on the graph of sine x? So first of all, if a is 1, let's make the value of a equal to 1. Still, you can see that here this red line is representing the graph. It is on x-axis. That means 1 sine x, 0 zeros. The remaining things are 0. Okay, if I change the value of b to 1, you can see the change in the graph now. When it is 1, value of b is 1. So, so far this graph you can say that this is sine of x. A is 1, b is 1. So 1 sine of 1x, c and d are 0 so far. So now this is the graph and its amplitude is 1. Okay, this number a from here represents the amplitude. Okay, if we increase the value of a, now please observe changes in the graph. So far this is its amplitude is 1. If I change it to 2, now this is 2. You can see that amplitude has become 2. And this is the cycle which we have discussed now. This is 360 degrees and it is continued afterwards even, and on this side. This is one cycle which we considered earlier. Okay, if I change the value to 3, now you can see that the amplitude is increased to 3, and 4, this value is now 4, and the amplitude is now 5. So this value of a over here, you can see clearly that this value of a changes its amplitude. So just try to recognize this value. This is transformation of the graph of sin x, that with change in value of this number, it stretches the graph along y-axis, and change in stretch along y-axis, that becomes amplitude of the graph. Okay, now you can see I have gradually increased 1 by 1, 2, 3, 4 and 5. Now, if I continuously move this value, you can change, you can see, observe the changes in the graph. Now look, if I move it back, here at 0, it becomes flat. And then as it moves towards negative, then the graph is now the reflection of that graph. You can see now that this maximum value is now downwards. It was upwards at this point. So you can see now from negative, this is negative, so this is downwards. As I move it towards positive, as the value of A will become positive, it will move upwards. You can see. You can see that this is inverted now. So this is reflection in x-axis. So as we change the value of x, its amplitude is changed. No other value is changed. You can see that the other points here on x-axis, they remain unchanged. So this value of A changes the amplitude. This is for amplitude. Now what is this value B for? Now look, as we increase the value of B, if we go on increasing, there are more cycles within, just focus on this interval from 0 to 5. If we decrease this value, the number of cycles are decreased in this interval. There are less number of cycles in this interval. And here you can see that by this number 5, its cycle is approximately 1.5. But if we increase this value, now you can see how many cycles are there. 1, 2, 3, more than 3 cycles are there. These are 4.3. If we increase this value, now there are so many cycles within this interval. So this value of B changes the number of cycles. Number of cycles means frequency. So in simple words, you can say that this number B stretches the graph horizontally with opposite to this number. If there is 4, that means its stretch factor is 1/4. In terms of transformation, you can use these terms that stretch, but in terms of this graph or waves, you can see that this is the number of cycles in one interval of 360 degrees. 4 cycles are there. So you can see how these numbers are changing with this negative sign. If it is negative, once again it is inverted, because sine minus theta is equal to minus sine theta. But one thing you should observe, that as we increase the value of B, frequency is increased, number of cycles are increased in the same, with the same scale, everything. Okay, now we just make it 1. Right, its amplitude at the moment is, let's change it to 2. Then what is the role of C? Okay, C is negative here. So when we move it towards positive, it is moving towards right. It is moving towards left. So this value C is its translation. Translation from right to left or left to right. If we change this sign to positive, then it will behave opposite to that. At the moment it is negative, so positive values of B, like C, like this is now 6. Here it will be minus 6. When it is minus 6, it moves 6 units towards right. But as we change the sign here, then it will move opposite to this value. So negative sign here tells us that values are negative, but it moves opposite to that. Now this is negative 1.5 when we replace this value, but it moves towards right. You can see if I increase that value, it moves further towards right. And moving this way, it moves towards left. So the value of C that moves this graph horizontally. This is horizontal slide. Now let's look what happens. Now this is plus D, positive. So you can see that the graph moves upwards and downwards, upwards and downwards. That means this is vertical slide, this is horizontal slide. Translation, you can say this is frequency and this is amplitude. So these are the things what we could observe here. Now let's come back here. If I write that expression here, y is equal to a sine bx minus c plus d. This changes amplitude. This value changes frequency of the graph. This value is horizontal translation. Horizontal translation. This value is for vertical translation. This value changes frequency, amplitude, and these things. If we change this sign, if it is positive, then the translation is minus C0. You know, we have already discussed in the topic of functions that this translation is opposite with this opposite sign. And D is vertical, so this is 0D as its translation, vertical translation. So these are very important things to understand and to apply in the questions. So this is the graph of sin x. Now the graph of cos and tangent, they are not actually these transformations and this type of things are same in all the graphs. So this was very important to understand its amplitude, frequency, and these things. So try to practice these things. Inshallah, later on we will do its past papers as well. So by that time, wish you all the best. Allah Hafiz.